Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Keam Prep, we're going to be continuing our discussion of some questions which were asked in the Kerala Engineering Architectural and Medical Examination. Now we're going to be looking at questions from the year 2020 and we're going to be discussing on how we can solve these questions effectively and understand them. So let's start off with a math question. The real part of e raised to 3 plus 4i is it e raised to 3x cos 7x, e raised to 3x cos 4x, or e raised to 3x sine 4x, or is it 0? So basically we're dealing with complex numbers here. So we have a complex number 3 plus 4i that is, present in, so e raised to 3 plus 4, the 3 plus 4i is present as an exponent of the exponential function, which is e. So how do we solve this question? We have e raised to 3 plus 4i. So this is our number, complex number here. So we can write e raised to 3 plus 4i as e raised to 3x times e raised to 4i times x. So basically we have to multiply an x here so that we can get an answer. So e raised to 3x times e raised to 4ix, and the reason why we were able to do that is because x can be multiplied to both 3 and 4i, and then 3x plus 4ix in the exponent means that it will be e raised to 3x times e raised to 4ix. So basically we are using a raised to m plus n as a raised to m into a raised to n, the law of exponents. So now that we've got that out of the way, we know that e raised to 3x is completely real because there is no imaginary number here. The exponent is real as well as e. So therefore e raised to 3x is a part of the real portion of this number. Now we know that e raised to 4ix is a complex term, and we're going to divide it into real and imaginary. So e raised to 4ix can be represented as cos of 4x plus I times sine of 4x. This is basically the formula e raised to theta I as equal to cos theta plus I sine theta. So if you were to represent the complex numbers in another form, then that is cos theta plus I times sine theta, and that's what we did. So now we know that cos 4x is the real part of e raised to 4ix, and since we know that e raised to 3x is also real, we can multiply those two, and the real part of the entire exponential function is option C, e raised to 3x times cos 4x. So therefore option C is the correct option for this question of mathematics. Let's look at another. If z equals x minus iy and z raised to 1 by 3 is p plus iq, then find out the value of 1 plus p squared, 1 by p squared plus q squared times x by p plus y by q. So how do we solve this question? We will use z raised to 1 by 3 as p plus iq. So the cube root of z is p plus iq. So therefore, if you want to find out the value of z, all you have to do is cube both sides. So z will now be equal to p plus iq, the whole cube. But we also know that z equals x minus iy, so therefore x minus iy equals p plus iq, the whole cube. So p plus iq, the whole cube, can be written as p cube plus 3p square iq plus 3p and then iq squared plus iq cubed. So since iq is taken as one term, so we have to cube both of them and square both of them. So this is basically the formula a plus b the whole cube that you've studied in algebra in grade 10. So on expanding this, so p cube stays the same, plus 3p square IQ also says the same, but we have 3p times I square q square, and since we know that I is under root of minus 1, I square will be minus 1. Similarly, I cube will be minus of I because it's minus 1 times I, and then I raised to 4 will be equal to 1. This is what we have studied in complex numbers, the value of I in its various exponents. So 3p times I square q square, that means you get minus 1 times 3pq squared. And since we have I cubed in the last term, so that will be minus I times q cubed. So now we can differentiate both of these into real and imaginary terms. So p cubed minus 3pq squared are the real terms here, and then the imaginary terms, the ones with the I, are 3p squared q minus q cubed. So x minus iy equals p squared minus 3pq squared plus I times 3p squared q minus q cubed. So now that we know of the real and imaginary parts, let's write them separately. So x equals p cubed minus 3pq squared, and since it's minus y minus iy that is present on the right hand side, therefore y will be equal to minus of 3p squared q minus q cubed. So now that we know the value of x and y, we will take out common terms here. So in x, p is common, and in y, q is common. So we take p and q to the left-hand side. So basically, we have x by p as equal to p squared minus 3q squared, and y by q as minus 3p squared plus q squared. Basically, I've put the minus inside the bracket. Now, let's add these two together. X by p plus y by q. That equals p squared minus 3q squared minus 3p squared plus q squared. So, p squared minus 3p squared gives you minus 2p squared, and then q squared minus 3q squared gives you minus 2q squared. So basically, it's minus 2 times p squared plus q squared. That is the value of x by p plus y by q. Let's take p squared plus q squared on the other side. So therefore, what we'll get is 1 by p squared plus q squared times x by p plus y by q. So this is what we have to answer in this question. The answer to this question is minus 2. So minus 2 is the correct answer. So therefore, if you're looking at the options, you can see that option A, minus 2, is the correct answer. All we had to do was to, expand the second, condition given to us and cube it. And after cubing it, just put in the given values. And then after that, cube the right-hand side. And after cubing right-hand side, algebraically, you will get into a condition where you will reach the question on the left-hand side, and the right-hand side will give you the answer, which is option A, minus 2. Now let's look at some questions of physics. 3 thin wires of equal length are suspended from the top of a roof. The respective ratio of their area of cross-section is 1:2:4, and Young's moduli is 4:2:1. Then the ratio of their weights to be attached at the other ends to obtain same elongation in them is 1:1:1, 1:2:4, 4:2:1, 2:√2:1, 1:√2:2. So here, we need to find a relation between Young's modulus, the area of cross-section of the wires, and the weights that is attached. So let's look at how we can calculate the Young's modulus. The Young's modulus Y is stress divided by strain. Stress divided by strain gives you any modulus of rigidity. And for Young's modulus, that means elongation. Now, stress, that is sigma, can be written as F divided by A, and strain is the difference between the is delta L, that is the elongation of the wire, divided by L, which was the earlier length of that wire. So F by A divided by delta L by L is the Young's modulus. So therefore, Y equals F by A times L divided by delta L. So that means Y equals force times the original length of the wire divided by area times the elongation of that wire. Now, in this particular question, the wires are of equal length. So let L be the length of the 3 wires. Similarly, all 3 wires obtain the same elongation in our particular condition. So therefore, delta L is same. So we'll consider that as delta L for all the 3 wires. What differs is the value of the Young's modulus, the force exerted, and the area of cross-section of each wires. And how do we find out the force exerted on the wire? That depends on the ratio of their weights. So therefore, we're basically finding out the ratio of F, because the weights attached to the thin wires at opposite ends will produce a force on that wire. Now, since we know the value of Young's modulus based on force, length, area, and elongation, let's find out the value of the force. Let's rephrase this equation so that we get F on the left-hand side, since that's the ratio we need to find out. So F equals Y times area times delta L divided by L. So delta L stands for elongation and L stands for, well, the length of the wire. So basically, it's Young's modulus times area times strain. So let's move forward. Now, for the wires 1, 2, and 3, we're now going to calculate the force on each of them. So we will consider A, 2A, and 4A to be the areas of cross-section, and we will consider 4Y, 2Y, and Y as the Young's moduli of those 3 wires. So, force 1, so force for the first wire, so it has a Young's modulus of 4Y, so it's 4Y times A times delta L divided by L, since that's the same. For wire 2, it is, so basically you get 4AY delta L divided by L. For the second wire, you get 2Y as the Young's modulus and 2A as the area of the cross-section, and then delta L by L, which is same for everyone. So 2Y times 2A gives you 4AY times delta L by L. So far, the force on 1 and 2 are the same. What about the force on 3? You have A, which is the area of cross-section, times 4Y. Actually, it's different. It's Y, that's the area of cross-section, times 4A, which is Y is the Young's modulus here, and 4A is the area of cross-section of the third wire, and then the strain remains the same, delta L by L. So therefore, you have 4AY times delta L divided by L. So as you can see, the force on all of these wires are the same. So if you were to take the ratio of the forces, F1 is to F2 is to F3, will be equal to 4AY delta L by L equals 4AY delta L by L equals 4AY delta L divided by L. So therefore, the correct ratio is 1 is to 1 is to 1. So therefore, the ratio of the weights attached to each end of the 3 wires is 1:1:1. So a similar amount of weight is attached to all of the 3 wires in order to exert equal force on that wire, on these wires. So therefore, the correct answer is option A, 1:1:1. Let's look at another question for physics. Water flows through a horizontal pipe of diameter 2 centimeters at a speed of 3 centimeters per second. The pipe has a nozzle of diameter 0.5 centimeters at one of its ends. So we need to find out the speed of water emerging from this nozzle. So basically we know that V1 is 3 centimeters per second. V2 is what we need to find out. D1 is 2 centimeters and D2 is 0.5 centimeters. Now, what is the fluid that is flowing through these pipes? It's water. And fluids in general and water in particular are incompressible. So therefore, the mass that's flowing through the pipe has to remain the same. And since these fluids are incompressible, therefore, the equation of continuity of area of a fluid, it holds. So since it holds, therefore, you can write rho times A1 times V1 as equal to rho times A2 times V2. Now, the rho cancels out because rho means the density of water, which is the same at both ends. And we need to find out the area of cross-section of the pipe and the volume of and the speed of the water. And that's how you can find out the total volume of water across both ends. And since they are equal, A1 V1 equals A2 V2. Now, the area that we get, the area of the cross-section of the pipe, is equal to the area of the circle. So that's pi r squared. Now, since r is d by 2, we can write pi times d squared divided by 4 as the area of cross-section of the nozzle or the pipe. So A1 is area of the pipe, so pi d1 squared by 4, and then V1, the left-hand side, the right-hand side will be pi times d2 squared, the diameter of the nozzle, divided by 4 times the speed of water at that nozzle. So pi by 4 gets cancelled from both ends. So what we get is V1 times d1 squared equals V2 times d2 squared. Now, since we know that V1 is 3 centimeters per second, D1 is 2 centimeters, and D2 is 0.5 centimeters, we just need to find V2. So V2 equals V1 times D1 squared divided by D2 squared. So that means V1 would be 3 centimeters, D1 squared is 2 squared, divided by D2 squared is 0.5 squared. So 3 times 2 squared will give you 3 times 4, divided by 0.5 squared is 0.25. Now we could start solving straight away, but since the denominator is in a decimal form, we can simplify that in order to make our calculations easier. So 3 times 4 is 12, divided by, let's make the denominator from 0.25 to 25. So when the denominator is made to 25, it has to be multiplied by 100. So since the denominator is multiplied by 100, we need to have the numerator also multiplied by 100. So 12 times 100 divided by 25 is the velocity of water passing through the nozzle. Now 25 goes into 100 4 times, so therefore the value of V2 is 12 times 4. Therefore, V2 is equal to 48 centimeters per second. So the correct answer for V2 is 48 centimeters per second. And among the following options, it's clear that option B is the correct answer for this question. So we are using Bernoulli's theorem and the equation for area of continuity for, mechanical properties of fluids. And from there, let's move on to some questions of chemistry. Adsorption is accompanied by decrease in enthalpy and decrease in entropy, increase in enthalpy and decrease in entropy, decrease in enthalpy and increase in entropy, increase in enthalpy and increase in entropy, no change in both. So, how do we solve this question? Well, in order to solve this question, we need to, analyze adsorption in detail. So basically, adsorption is the process in which molecules called adsorbates are attached to the surface of an adsorbent, which is a large, which is a larger or a different, compound that can attach molecules of the adsorbate on its surface. So when the molecules of the adsorbate are attached to the surface of the adsorbent, we call that adsorption. So when they're attached to the surface of the adsorbent, the molecules become less random. And when they become less random, they have less entropy. So basically, a decrease in entropy happens in adsorption. So this means that option C, D, and E are incorrect because they either say increase or no change in entropy, whereas in fact it's actually decreasing. Now, how do we decide on enthalpy, whether it's increasing or decreasing? Well, this process, adsorbates are attached to the surface of the adsorbent, is always exothermic. The reason being that since the intermolecular attraction of the adsorbent molecules makes the surface molecules wanting to attract, other molecules so that they can release their energy, this means that adsorption is always exothermic. And whenever a process is exothermic, delta H, or the change in enthalpy, is negative. And when the change in enthalpy is negative, then enthalpy decreases. So therefore, option B, increase in enthalpy and decrease in entropy, is incorrect. The correct answer is that adsorption is accompanied by a decrease in both enthalpy and entropy. An example for adsorption is the drying up of shoes and other products using silica gels, which adsorb water. Now, the next question. This is the final question of this episode. In the coagulation of a positive sol, the flocculating power of the ions PO43-, SO42-, and Cl- decreases in the order PO43- less than greater than Cl greater than SO42-, and here are the other orders present. So, which of these is the correct order of the decrease, is the correct, representation of the decreasing order of the flocculating power of the ions in question? Well, in order to find that out, we need to find out how the coagulating power is dependent on the ion. When you're talking about coagulation, the coagulating power of an ion is directly proportional to its valency. So therefore, since the coagulating power is directly proportional to its valency, therefore, if you have a positive sol that needs to be coagulated, the coagulating power is highest as ion becomes more negative. So if your ion is more negative, then its coagulating power is highest. Now over here you have PO4 minus, SO4 minus, and Cl minus. So that means PO4 minus has the highest flocculating power, and Cl minus has the lowest flocculating power. And since the reason being we are using these ions against a positive soul. So if you were to write the decreasing order, so we're writing the descending order here, so that means the most powerful comes first. So PO4 minus should come first. That makes C, D, and E incorrect. Then we have the next powerful, so that means the ion with the next highest number of the next highest valency, which in this case is SO4 minus. So that means option A also becomes incorrect. The correct answer is option B. PO4 minus is greater than SO4 minus, is greater than Cl minus in terms of flocculating power of the ions in the coagulation of a positive soul. So that concludes this episode of Keam Prep. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, Brain Blitz Audios. We have various mind maps based on the chapters in Keam, which can help you out for last-minute preparation. If you want to get our latest updates, then don't forget to hit the bell icon that's present below the video. Also, if you want to access the playlist for NEAT, then please don't forget to hit the playlists link, which is present in the description box down below. If you have any queries or quibbles, then you can always use the comment section down below to ask your doubts. So until the next webisode, take care, stay safe, bye-bye for now.